We're working on page 12 of our 8.4 notes. I'm going to brighten the screen a little bit. It's a little dark. I'm going to let you in on a little property that's actually introduced in the next section, which we're not going to get to, and it will help us with these and a couple of them on the next page. It's called the inverse log property, and it says that once you've rewritten this with an exponent, so 2 to the first power, and then the index always becomes the denominator. The inverse log property says if the base of the log and the base of the exponent are the same, they undo each other, and the answer is just the exponent. Cool, huh? So look over here. We wrote square root 5, which is 5 to the first power, so 1 over 2. The base of the log is the same thing as the base of the exponent, so they undo each other, and the answer is just the exponent. So in this one, we couldn't do that, of course, unless you wrote this as 7 to the negative 2 first. So if you had written log base 7 and then made that 7 to the negative 2 right at the get-go, because it's 1 over 7 squared, which is really 7 to the negative 2, then look at that. There's the inverse log property, and the answer is the exponent. And you could have even done it with this one. 64 is 4 cubed. So if you had recognized that, you could have said, oh, log base 4, 64 is 4 times 4 times 4. Oh, look at inverse log property. These undo each other. The answer is the exponent. So anytime you see to do that, it's kind of a little shortcut and you don't have to do the algebra stuff. So that's called the inverse log property. And you'll see it a lot in Math 150. So as I was booting up the next video, I thought I should show them that, even though we're not going to get to 8.5. That's a cool little property to know about. So let's see if we can apply it. So the base of the log is 4. The base of the exponent is 4. So this is an inverse log property. So the answer is just the exponent, which is 9. So we don't even have to do any work. Cool, huh? Same thing here. Look at the base of the log is b. The base of the exponent is b. So my answer is just the exponent, which is 75. So that's called the inverse property of logarithms. And what it says is, since exponents and logs are inverses, when the base of the log is the same as the base of the exponent, they undo each other, and the answer is just the exponent. Okay, so let's go to the next page. This first set of exercises, number 3, these will also be no calculator problems on your test next semester. So we're going to do them without a calculator. The second ones you can't do without a calculator, so we will do those. I'll show you where the log key is and all that good stuff. So a logarithm function with a base of 10 is called the common logarithmic function. And the reason that's so is because we have a base 10 number system. So when the log has a base 10, we call it the common log for short. So when we see this, for instance, y equals log of x, it's really y equals log base 10 of x. But because it's our common log, we can leave it off. It's kind of like when you see x. You know there's an imaginary 1 here and an imaginary 1 exponent. Well, the same thing. If a log doesn't have a base, if there's no base written there, see how there's nothing down low, you can assume that it's 10. So we rarely, if ever, write it like this. We use this form. And there's one other log that you'll learn in 150 that's actually 2 sections away from this that we're not going to get to, and that's the base E log, which is the natural log. So there's base 10 log, which is the common log, and then there's a log with base E, and it's called the natural log. And if you look on your calculator, it has both of them. So this is log base 10, and this is log base E. So the natural log is written ln. It's logarithmia natural. It's a Latin word. That's why it's ln instead of nl. Because students always go, if it's natural log, why don't they call it nl? But because it was a Latin word, that's why it's ln. So logarithmia natural, something like that. And that's base E. And you can see up above they have e to the x, and up above log they have 10 to the x. Those are inverses. So this is the exponential, this is the log. This is the exponential, this is the natural log. So their inverses are on top of them. But anytime you have a base 10, you can use this. Anytime you have a base E, you can use that key. So this section is on the common log, base 10. So if you look at number 3, and like I said, you should be able to do these without a calculator in the next class. So we're going to do them without a calculator now. So I see these are all powers of 10. So I'm thinking, why don't we use that inverse property of logarithms that says if the base of the log and the base of the exponent are the same, the answer is just the exponent. So that's my goal, is to make each of these look like that. So does everyone agree each of the bases are 10? So I can write 10 in there, 10 in there, because it's assumed. So if something doesn't have a base, you can put the 10 in. So this is really log base 10, 10 to the, so let's see, 10 to the third is 1,000, 10 to the fourth, 10,000. So this is really 10 to the fourth. See why I did that? And you know it anyway because it's based on how many zeros it has. 1, 2, 3, 4. That's why it's 10 to the fourth. So guess what my answer is? Ding, ding, ding. It's the exponent, because the base of the log and the base of the exponent are the same, so they undo each other. So my answer is just the exponent. So let's do one more together, and then you guys can try one. So tenths, hundredths, thousandths, 10,000ths, 100,000ths. So this is really log base 10, 1 over 100,000. You guys remember that from your way back basic math days? So tenths, hundredths, thousandths, 10,000ths, 100,000ths. So it's 1 over 100,000ths, and that's red, 1 100,000ths. Well, I can see this is a base of 10. It has 1, 2, 3, 4, 5 zeros, so it's 10 to the fifth. But remember on page 1 how I told you move this up and it becomes 10 to the negative fifth. So this is back from chapter 4. When you move an exponent from side to side on the fraction, its exponent changes sign. So if it's 10 to fifth in the denominator, it's 10 to the negative 5 in the numerator. So now I can tell the answer. The base of the log, the base of the exponent are the same, so the answer is the exponent. So turn off your video and try C. C is just like B, so you should be able to do that. So see if you can do that one on your own if you're getting the hang of this, okay? Because it's the last one we have before we start using the calculator. Okay, I'm going to do the work up here. So this is log base 10, 1 over 3 zeros, so that would be 10 to the third. And you can test it. 10 times 10 is 100, times 10 is 1,000. Yep. But we don't want a fraction there. We want it to be a whole number base. So we bring that up and it turns into log base 10, 10 to the negative 3. So usually we're trying to make the exponent positive, so we bring it down. But in this case, we want our bases to be the same, so we bring it up, and that makes the exponent become negative. But now you can see my answer is, boom, negative 3. I told you this was a fun section. So the base of the exponent and the base of the log are the same, so their inverse property undo each other, and the answer is the exponent. So yeah, when you do those on Connect Math, I would try to do them by hand, not with the calculator, because you have to do them by hand in the next class, so you need to know how to do them. And then there's some that aren't powers of 10, so we do have to use the calculator. So let's see what that looks like. So this is base 10. See how there's no number there? So we're going to use this key. So we do log, type in 250, close your argument, and this assumes it's going to be 10. And it says round to 4 decimal places. So the reason they do 4 is because back in the olden days when your teacher was in school, we had to use log tables. We didn't have calculators. I don't think I used a calculator till college, and it was a big clunky calculator. But we had to look in the back of books for the logarithms. They had like these tables and tables and tables of all the logarithms. And they were all rounded to 4 places. So to be consistent, usually you'll see that logarithms, they ask you to round to 4 places for that reason. So 1, 2, 3, 4, right? 4 decimal places. 9 followed by 4 says keep a 9. So 2.3979. And like I said, you can't do, well, you probably could do them by hand, but we don't do these by hand. We use a calculator. So anytime it says round, you know that's a calculator problem. Okay, let's try the next one. So log 2.456, close 3, excuse me, 0.3902 followed by a 2 says leave it 2. So 0.3902. And these really should be squigglies, not equals, because they're not exact answers, they're rounded answers. Same thing here. And this one's no different. You just type it exactly like you see it. So log, the parentheses already there, 2.4 times 10. And then remember we have to use the caret key when there's an exponent, caret 4. So 2.4 times 10 to the 4, close your parentheses, 4.3802. And we don't change the 2 because it's followed by a 1. So it's either keep it 2 or bump it up, but because it's followed by a 1, we keep it 2. And I see we only have 45 seconds, so I am going to start the graphs of logarithms on the next video.